Well, Chris asked me yesterday to give a presentation because Koen was getting ill. I was oh God, my goodness, what am I going to tell you guys? But I had a presentation early on, and I would like to give you that. Some of you guys probably know this picture. More the older of you. Back to the Future. This is the picture of Back to the Future, where Marty is going to back in time. So we are going to do also the same thing now. So this is the present time, it's today. And I'm going back in time to 2016. And 2016 I gave this presentation. And that presentation covers the time from 2013. Because 2013, the change on the mortgage, from the mortgage part, and we had a provision on mortgages wasn't necessary, wasn't able to do that. So people are actually going to pay for advice and mortgages. So you're going to buy a house, you have to pay an advice for the advice. It was not a provision part. And we built an application for that, and on that time, it's called the Rabobank Hypotheek Dossier. And we started in 2012, and 2013 we went live. And when we went live, we had a number of two teams, we're building on it. And one of the discussions we had when we went live is how we're going to do our delivery. Common Good was on that time a quarterly and half-year time frame for going to production. And we said, well, that's not what we're going to do. We're going to do that differently. And I'm going to talk to you about that time frame from 2013 to 2016. So I went back on time and take you with your journey on that. Who am I? Now, some of you guys know me, but I'm Robert-Jan Peters. I'm lead solution architect on the mortgages. Rabobank Hypotheek Dossier is one of our applications. I'm a member of the Java community within the Rabobank. I'm also a member of the API Guild. We have public APIs on PSD2, and I'm part of the API Guild. I'm self-employed, and I'm a part-time developer. So I'm still coding Java, but also .NET, but also JavaScript, Node.js, and Groovy. Those are my things to do. One of the things what actually driven us is business value. When we started in 2013, the main objective was to deliver business value. That's one of the things of the Agile Manifesto I like the most, is only software that's being in production actually delivers value. How many times have seen that we came to the auto environment, the dev environment, acceptance environment, but we never took the step to the production. And not in production, you don't deliver the value. So one of the main objectives was, for every change we do, it should be going to production, and that as fast as possible. Because another concept we do is feedback. My previous presenter was actually talking about feedback and getting feedback on different levels and how you're going to get feedback. So that was the most important part what we had in the value chain, going to get feedback and then delivers value to our customers. And the customers, we have two types of customers. We have customers in the outside world, mainly in the domestic of the Netherlands, buying houses, and we have our employees, they're working for the local branches and doing the advisory on mortgages and maintenance on mortgages. So that was our target. As we discussed earlier, was the main delivery velocity within the bank was in half year. Part to the CBIL, that's our CRM, customer relationship management system, and that has a delivery time of 6 months with testing, etc., etc. But that means that we want to make it faster because we had a backlog for delivering extra value, what we couldn't solve within the first half year of our existence. So we had two things we did. Was first to extend our teams. We went for a short time from 2 teams to 8 teams, and how we're going to do that. And the second time what we did was to actually go into DevOps. DevOps was, in that time, 2013 I'm talking about, was mainly within our organization. You have devs, those are the devils, those are the mean guys, and you have ops, those are the guardians, the guys that know that they take care of the application and production. And that's one of the things what we did is to put those people together, not organizationally, but within a delivery. We went from half year to a monthly delivery. That means that the people of the development and the people of the ops environment should join together to go into production. And that was very hard in the beginning, because lots of things weren't automated. We had a very hybrid environment, and they didn't understand each other. And development is only going to the acceptance environment, and that's not my problem anymore. And the ops environment say, okay, but the acceptance is my starting point, and then going to production. But it means if you want to do that on a monthly basis, then you actually need to join together and to go to do that. And we did that on two things. First, we put those guys together in one room for doing that. So on the monthly release, that was on the Thursday at 6 o'clock in the morning, we did that. We put the guys together and we did our deployment. And it took a number of hours at the beginning, but later on we went to a faster velocity. And one of the things that we drove over here was the feedback cycle, but also if you are not having any pain, then you aren't going too fast enough. That's some of the drovers, they say that if you are not having, if you are sitting and relaxing behind your steer and you're driving not fast enough. So that's what we did. We increased the number of times we go into production, and we shortened the time frame. So everything that hurts, we had to solve that. So that part, we had increased the learning capabilities of the teams. And then we did that by putting continuous delivery and continuous integration and continuous delivery at the first place. So teams enjoy that, and we did that by a joint effort for increasing and improving the process, the tooling, and the other things. Well, one of the things they had is, my previous spoken, we used Splunk at that time. 2013, we were the first to initiate the Splunk environment, and we'll talk you later on that. We don't use that anymore now. Rabobank implemented this shape. At 2016, we had 8 Scrum teams, 7-8 people by team. That was at that moment actually DevOps. We had a flat hierarchy, so everyone can actually doing things in production. We have a flat structure. Everyone with our team, and we still do that, is a DevOps engineer. And we have some God modes, but those are maintaining some of the stuff. But everyone has the same rights and the same privileges. We have more than 200,000 cases of lines of code. Not as much as by previous spoken, but we have that is our department. Our source control is Git at the moment. We went from CVS to Git. We were one of the initiatives for doing that. At that time, we had 100 builds a week. Nowadays, we have multiple times that. Then we went to weekly to go to production in 2016. Today, we are going to multiple times to production in our environment. As I mentioned, there's an internet-based application. We do testing on Firefox, on Chrome, on mobile devices like Android and iOS, and all the steps are automated. That's one of the building blocks we have. Our application is a web-based application. People can advise and orient it on mortgages, and if they enter their income, they can get the max to loan, what the actual amount of money they can loan from, for instance, the Rabobank. Our application at that time was mainly 4 pieces. We had the statics, we had a portal environment, we had an application layer, and we have a database layer. That's our application, and this is simultaneously deployed to an environment within our bank. This, currently the Rabobank internet environment is still mainly this type of application. We are going to change it probably here in JFL. I don't know if some of you guys went last year, but we're going to PCF, Pivotal Cloud Foundry, as our main microservice platform. We do it different, it's a little bit different, but this is at that time our environment. Nowadays, this is a microservice environment with approximately 120 microservices. I'm going to have a talk later on that calls the building a bonsai pipeline, and it's going further on how to handle and to manage multiple microservices in one handle, how you can do. What we did over here is also, this is one delivery and one deployment unit. So this one version what we deployed. So the monolith is well known over here. But how are we going to handle that? If you mentioned in 2013, how are we going to increase ourselves? Velocity was one, feedback is another one. So how are we going to do that? Now we defined a number of building blocks, and if you look into the CI/CD maturity level, then you can pinpoint some of these building blocks on it. And I'm going to talk you through it, how our journey walked. And each one is a leap for going on. So you have the leap of repeatable, predictable, and we'll talk about it later, and then going to the next leap, and well, eventually you're going to raise on the scale, and you start getting more functionality and more enables for doing software delivery. So one of the first things we did at that time was to make our environment repeatable, predictable, and reliable. Teams need to have these. Otherwise, teams are going to waste time on things they don't understand or what's unpredictable. One of the things we had at that time was the configuration of our different stages. We have a development stage, we have a test stage, an acceptance stage, the production stage. They were different. Took one of the environments, and the environment had multiple machines, they differed. So a test could be failing on one machine and working on the other. And probably most of the time that was the reason was difference in configuration. So what we did make it repeatable. So our environment, and we were upfront at that time, our environment was standardized. We only use one typical configuration for deploying and building our system. That time we went to Git. CVS was at that time one of the source control systems for Java, and we went to Git for enabling so we can access that from each of the machines. So we had one machine, we had one way for accessing our Git environment. So we had Linux environments over here, a Windows environment, and we got them all. Mainframe we didn't, but those we had. So that was also part of changing configurations. So that was one of the things that the teams can rely on. So if they were going to build it, it is always built on the same way. My time is independent, so that's the same thing. So you're going to build it and you're going to build it the next time, so it should be the same. So our run infrastructure ecosystem is evolved, and we created and built infrastructure that has been evolved. And that makes it possible to more standardize and going to the next level. And the next level was automate everything. There is no way, there's no alternative than automate everything. The simplest thing, we automate. So provisioning of our systems were Ansible scripts. We did that in 2013, making Ansible scripts for deploying our environment. We were at that time one of the outlaws within the Rabobank, because everyone uses HP stuff like HP operations, etc. for deploying that. But that didn't give us the repeatability. So if one machine is going down, we want to do a new order within the IT shop. That's one of the parts of ordering a machine. And we order the machine and we put the Ansible script on, and then we have the same, each time the same configuration. And we did that for our runtime environment, but we did also that for our build environment. So we used the Jenkins machine, or Jenkins environment, and each of the slaves had the same configuration. So teams came to me and said, okay, this build doesn't work. Well, most of the time, they say, well, it is part of the environment we're running. There's a difference. So that isn't possible because we use the same scripting for deploying our Java standard, our Maven standard, our NPM standard. All those things are within the same configuration, the same lifecycle management. So, well, first check your own code, check your own tests, and then come back on me. And well, that doesn't take it that we hadn't any problems with that, but then it was repeatable. If I take another machine and the same test, then it was also failing. At that time, we also automate our test environment. We did local testing, but that wasn't giving us the velocity because we want to increase that from monthly to weekly to weekly and to a daily one. That was our objective to do. And testing with manually is very hard to do, so that's one of the things that we also created here. And we had lots of discussion with our IT departments because they didn't supply us with the necessary configuration, our necessary Windows environment or the necessary Mac environment, because that's one of the applications we also do. And that's why we started to build our own Selenium grid, and that is also automated. So we had our own automated Selenium grid with multiple OS and with multiple versions and with multiple browsers. That's very hard to do, so that's not easy, but it's very hard what we did, and we had some fallbacks, but that was the time to do. As I mentioned, also a monolith is a web server environment. One of the things we had was our web server environment, our portal environment, and our application environments. I mentioned earlier in my picture what different deployment tooling. Well, it's very hard, and it was the different deployment tooling, not alone in the test environment, but also in acceptance environment and also in production environment. You guys probably understand, can recognize that. So one of the things we also did was our own deployment descriptor. You don't care if you do it in test, or you do it in acceptance, or you do it in production, it's all the same. It's the same way we do that. We have the same configuration, we have the same way to handle variables, we have the same way for going to do that. And that makes it possible because what we did was make it repeatable. We can also automate that. And the teams get time available for doing other stuff. So quality was some of our colleagues mean quality is a cost-based, so you should optimize that. What we got enabled with these steps is that teams tend to have more time available, and that we could look into other things. So our quality standards raise. So at that time we had a quality standard of code coverage of 70–80%. Nowadays we do code quality of code coverage of 93%. Well, you can have discussion about the height, but that should be the case. You should discuss what is a good quality and how you're going to handle that. But our new applications have that type of code quality. That means also that we had time available for performance testing. Doing a regular performance testing now, I don't know how you guys do that, but at that time we had once a month and performance test. Nowadays, we run each time we go into production a performance test. We have two types of performance tests. That's a 10-minute test, because we have a microservices and we have 10 minutes, and that's a good guess for not failing within 24 hours on memory leak, etc. And we have a longer performance test, an hour. But that was done because we could do this. The second thing, or the third thing that we have, or would be enabled, was security testing. Probably you guys do once a time, a number of months, security testing, pen test, but that we did also that. But now nowadays we do that with each time we go into production. We have a small security test, and we have a large pen test by a security guy. So aside from the Cyber Defense Center, there's an organization with us, does that once and a half year, a year by some application. Because also, and that means that I'm going to the next leap we had is sharing artifacts, is by making small batches. In the early days we had long batches, monthly changes, that's a lot. If you have 8 teams working on the same application, because they're working on the same application, you have monthly changes of 8 teams, that's a lot. There's a lot of changes. That was smaller than in a half year, but it's still a lot. So how are you going to handle all the changes and do a good estimate on the risk you're having when you go into production? So my previous speaker talked about snapshots. At that time, we got rid of snapshots. We don't do any snapshot anymore. So you build it, and that's going to production. That's a release candidate, and a release candidate can fail when you don't meet your quality gates. And the quality gate can a test. It could be an integration test. It could be a chain test. It could be a performance test, security test, etc. It fails, and then it's vaporized in our repository. That means that every release candidate can be built once and only once, and you can audit which changes are going in there. Like my previous, we had the standard for making our JIRA item, putting in the commit message, and we can trace that, which one is going to do. Google has a nice form that our front-end developers are fond of it, has a nice form for committing messages and the standard for committing messages. Those times we're going to use that. That's one of the things we also going to use now on auditable, on which changes do affect which risks in our application. So we have a risk matrix, and the risk matrix is being drilled down to the actual commit, and the actual commit can be put back to the actual risk we had. So it is in Java based and NPM based. Java has the release plugin. We don't use that anymore. What we actually do here is to use more extensively of the next staging. I don't know if you guys know next staging, but next staging is a way for handling non-snapshots. We're going to a stage repository, you can put it in there, and if it's time lapse, it vaporizes, and you can actually promote it to production. So one of the things you had, what we got was, by building that fast, you get lots of snapshots. And which snaps you're going to pick up for going to production, and are you going to test it with the right one? And you can actually see what type or what artifact you're going to build, and you put it into production, that you have also the clean test for that. And that's very hard to do. So we introduced the Nexus staging environment, and so we don't build any snapshots anymore, and we use the staging environment of Nexus. There's a very good function of Nexus is that. So we have the shared environment, we have the shared artifacts, we can pinpoint which type of application is to production and which tests have been run and which changes have been putting in there. So the other thing we got over here is that every change is going to production, and we're going to handle that if a feature isn't complete. So that makes us using the decouplement between a deployment and a release. So everything is going to production as a deployment, but shouldn't be in a release. And that makes the use of release candidates. And now release toggles, so feature, dark features, etc., is one of the things we introduce over here. So it is going to production only behind a release toggle or dark feature. That's also called. One of the other things what we had over here is that people tend to use Git flow. what's a very workflow environment for Git, and most of the developers use that because they are sitting in a cocoon, and the cocoon is very easy, so you don't have to merge in, merge back, but it makes it very hard to go and to get a feedback cycle back. So one of the things we did on that time, and I'm still struggling that with lots of developers on coming, is we do mainline development. I don't know if you guys know what mainline development is, or trunk-based development. It means that everything is committed on the main line. That doesn't mean that we don't use short-lived branches. So if people using a story, they are going to build a short-lived branch, but the short-lived branch should be only available a couple of days, and then it should be merged into the main line. Other projects or other teams actually do mainline, and they even don't use the short-lived branches. This means that you have less commit failures, merge failures, and your feedback cycle for your own development is very fast. Yes?
So, just maybe refresh my memory, how do you release?
From mainline.
From mainline.
Master, yeah. Release from master.
Right.
And if you're going to build, if we build the release candidate, the actual release candidate is tagged also in the Git repository.
Mm-hmm.
So you can actually, the production version you can pinpoint back to the Git repository. So this is actually going to production. Sometimes each commit is going to production too. We have teams that are doing that currently. So multiple times a day can be one feature going multiple times a day to production. That means that our feedback cycle was shortened again, and makes it possible for going to another deployment model. That's what we also hear is going to a Mrs. Marathon or PCF platform where we actually can host microservices, and that increases the velocity of the teams. For doing that, we build pipelines. And the main objective of a pipeline is to actually transport a commit done by a developer into production. That's the main purpose of a pipeline. And you do that amongst the different environments, and you keep track of quality, reliability, and stability. So at that point we had the central Jenkins environment, but because we did a lot of builds, you come up in a queue, and that queue delays our team. So this was also one of the initiatives for moving that to our own environment, on our own pipeline, our own Jenkins environment, which we maintain with one guy for 8 teams. So pipelines are multiple pipelines. This what we did was on the previous Jenkins, so Jenkins 1, where you actually build the jobs. Now we're going to pipelines the code, so we actually go there. And everything, as I mentioned, is automated. So the database, you probably saw that, remember that in my first slide. That's also what we actually changed, automated. We did some tooling that was our Oracle tooling from our Oracle department, but that didn't suit our needs. So one of the things that we look into other tooling, and one of is we use Flyway, but the other is
Liquid-based.
Liquid-based. Yeah, we use Liquid-based. We did that for a year, and we got into some of the troubles. Well, at that time, XML wasn't that sexy for developers. They want to have it non-XML, but there were some other things that didn't match our needs. So that's why we went to Flyway, and Flyway, that's how we manage our database. So our Oracle changes are doing by Flyway, and our database is 1.2, now 2.8 terabyte data inside. So that's how we automatically did that. And that time, as a different step, nowadays it's part of our Spring Boot application. So if the application starts, it'll go into the state of the database, and it automatically changes the scheme of the database and do some data migration on it. Within the pipeline, Also, at that time, we introduced the Selenium Grid, as I mentioned, for doing remote testing. Mobile testing was the next step, but also automated performance testing during the night, and security testing also during the night, and well, the short one is during the delivery at this time. And it is being pushed into the web server environment within this, within building pipelines, and nowadays it's going to Mrs. Marathon, and it is going to PCF. What was the interesting part for doing this is that we got rid of a number of environments. So we had the test environment, we had the acceptance environment, we had production environment, and we have an XPT that's called the performance environment for the long journey tests. And we started with doing that in this leap for eliminating environments. That was very hard for the business for doing that, but we actually did that. So we removed a number of environments, and nowadays we have our test environment and we have our production environment. And the test environment is build and destroy. So you pick up the environment, you build it, you run your test, and you destroy your total environment, and then go further in your pipeline for the next quality step. So that makes a huge reduction in the number of steps you should take, but also costs. Because running an environment, well, lots of the time it only consumes CO2, it produces heat, but the number of usage during a day is very, very, very small. So by going to another deploy model and going to pipelines, we actually make a reduction on the number of environments to support, and the environments that we support are in build and destroy, deploy and destroy part. Well, doing all of those things, monitoring. As I mentioned, we had the HP environment for logging that didn't suit our needs, and we went to Splunk. We did that with the 50K on license, so you could add that with buying the total license, and we did monitoring on infrastructure. So our applications on the different environments are making the log files, and the log files are being consumed by Splunk, and they report that. We make lots of dashboarding on that, the teams itself, because as I mentioned, we have DEVOPS, so each and everyone is responsible for the running environment. You build it, so you run it, and we did that very successful. However, then we want to do also build monitoring, as my previous presenter did. So how many times were you built? How are your tests? How are your commits? That was a different approach. That's more a push system than a pull system. Even though we're going to the microservice environment, so going to Mrs. Marathon, and one of the things we did was you don't have any access on your environment. Why log on a machine? I don't care that there is a log file, you don't have any log files, because you don't have any storage in your microservices or Docker environment, because we also do Docker. How are we going to do that? At that time, we went to the Arc stack. So Elastic, Logstash, and Kibana, and we went away from Splunk, because at that time Splunk was going huge. So having served our team, it took a long time for enabling more functionality. Well, there was a lot of new customers and changes in that. It took a month or 6 months for adding new functionality. So that's what we changed to the Elastic stack. And nowadays we use the Nexus stack for our microservices. We use our Elastic stack for monitoring our build environment, and we also add alerting and watching and alerts and watches. So if there is a metrics from Spring Boot, people or the teams can make their own metrics on that, make their own watches, and do the SMS or PagerDuty integration for sending the alerts to the teams. So most of the time, the teams have already have their own alerting enabled before we see troubles in production. that makes that the teams are self-sufficient. That's also what we changed now. We had 10 teams. 10 teams had the same operations, and now we share the person of the day, that one who is on call, and we're going to make that more decentralized. So we have a centralized person for 8 teams for more common stuff, and each of the microservices or a combination of microservices is being handled by a number of teams. That also introduces another thing. What you have is that our CMDB should be enabled for doing that. So one of the things we actually do is to enable our CMDB, and that's only for our part within the Rabobank organization, not the other. So if you're going to another department, you will probably see a totally different approach. But for us, we have the CMDB environment with also the major functions and the microservices and the digital. So that's being done by the CMDB. What we don't register is our hardware, because we are running in Azure, and well, it's a cattle approach. What we did was on the web server environment, you had the PAT approach. You probably know PAT is, you tend to love that, to share that, to make your own, and now it's a cattle. If it starves, and you run it again, and it will be put on a new one. If your application start message marathon, singular is that, and start as a new application. However, so test built on infra, as I mentioned, we have lots of dashboarding on what each of the application and also each of the team for doing that. Let's start with culture. Our main learning point in culture is that you have to bring people together. They need to share the same objective. What we saw with the development guys and the operation guys, we put them together and make them share knowledge, but also share the same responsibilities. We don't have development has more or less authorizations than the operation part. You all share the same operation. You all share the same authorizations, and you act within your competence boundaries. So in junior, won't be doing a very complex handling within the in the production environment. You tend to do that on pair. There's a very good extreme programming principle. You share that with one of your peers for doing that. One of the other things is not a blame culture. A production incident is a learning thing. So what we do a post-mortem with all the stakeholders regarding that production incident. And we make a timeline what happened during the time of the production incident, and who has the which responsibility, who has this, which action to take to learn and to make it better. Don't blame, because if you're going to blame, people tend to take back and not share knowledge and not share working to a solution for the problem. So the number of production incidents are very, very low. And I mean, we have some peaks and that's it, but 1 or 2 production incidents in a quarter or 2 months on one system is very, very common. The other thing is, teams tend to go to the cocoon. Developers tend to the cocoon. Don't use the cocoon. Talk to each other. What we do is to have also brain bits, that's knowledge sharing on the Thursday, where people tend to explain things that they're working on, or what their hobby is, and a hobby on the IT part, not hobby on their what they do private, but what part of the system they work on, what new technology they have, to share that with other people and to talk about that. Pairing is also a thing, and not only pairing within the team, but also over teams. You do learn much more if looking and joining other teams. In a microservice environment, that's still more practice than doing it in Monolith. In Monolith, you come to each other because you share the same code. If you go into a microservice environment, you probably don't share code. Code ownership is not of the team. we have a department, our 8 teams, and we share the code among the teams. Everyone commit on everything. Well, please make a jest or going to that team. You're going to commit that, and please can you approve that going to production, because we have a 4I principle or 2M principle for going to production. And one of the team that has ownership, or not ownership, guardianship, because it's the guardian of that component, actually approves the going to production. And that's all being logged for auditability, who is going to approve that, and which type of application, or at what time it's going to production, and how many times does that. So we do peer reviews. That's also very part of culture. Learning from each other, seeing other code bases, seeing other constructions makes you more mature in your development. How it's done? Well, this is probably a little bit outdated, but what we did in 2016 was this our pipeline with the products we use. Now, some of them are not there anymore, and some of them have been introduced on that. So we have shown 45 check marks we're going to do to make a migration to check marks. Cucumber, Maven, Git, NPM, Protector. I'll call them more the technology stack we have. On running as Massive Marathon, we are looking to Kubernetes. Azure is an environment we're running on. We have some of the things on-prem, some of the things are in Azure. We have a private and public Azure private space. We have our own subscription on that. So this is our current technology stack, or part of the technology stack. We have still challenges. This was mainly 2016. We're currently 2019. Lots of have changed, but the same leaps we still have. So we have now a very tremendous change of people, developers. Lots of people are going out and lots of people coming in. How are we going to have the same way of working, the same maturity? How are we going to do that? How are we going to introduce our stakeholders more upfront in the development process? We did some experiments with behavioral driven development, BDD, but that wasn't feasible. So that's one of the things we're going to introduce that again. What we also have, we have external suppliers. We have our philosophy of delivery multiple times a day. How are we going to incorporate our suppliers on that for packages which we have in our organization, the mortgages part. So how am I going to do that? One of the things is going to chainless and actually changeless. So in our first environment, we had each component with our value chains was an environment there. Nowadays, it isn't. So how are we going to handle that? How are we going to do our tests hygiene? And from the different levels, we have the test pyramid on several levels. So your unit test, your component test, your journey test, your end users test. How are you going to do that at the hygiene? How are you going to manage those risks? And who is responsible for doing that within the team? Because one of the disciplines that is not there anymore is a tester. We have a T-shaped team where everyone is a DevOps engineer, but has a specialty on development or testing. And testing, the pure tester, we don't have that one, and not anymore. So how are we going to do that? Zero downtime we already did, but how are we going to do more blue-green deployments also did, but more canary testing, and that with our business parts and with our business reps also part of it for doing that. So that are challenges we still have. What we see is that by doing those leaps, you get more time available, and people tend to see more what you have done, and because first a time lapse on response time for 500 milliseconds was very good. Now we have a deviation of 2 milliseconds, and that is a huge problem. But this is a problem because we can measure it now. And in the total time, that's not a problem because CRMI, that's one of the system, has sometimes a time response of 3-4 milliseconds. So we're talking about that time of deviation. So still lots of do, but the main thing is to share, to constantly improve, to make and join with the product owner for getting not only functionals but also non-functionals. And that should be also aware that the product owner is aware of the non-functionals, because if your non-functional is not working, your application is not working, it's not going to production, and not going to production means no business value. Thank you very much, and hope you enjoy this talk. Any questions, please ask or come later by me.
You mentioned you create test environments on the fly and destroy them. Do you do any chain testing, or is it in isolation per service?
We do both. We have isolation of one single microservices, but we have a partially chain that's under our control. So that's multiple microservices that the teams deliver, and that one we also test in combination. So we build a so-called ARI tool. An ARI tool means that test management, test data management is a very important thing. Lots of our environment is stub. We use WireMock for that. We do contract-based testing. So on a lower level we use consumer-driven contract testing, and on a higher level we use that same consumer-driven contracts for initiating the stubs and to inject the test data and run a complete test journey, particularly for a number of microservices, and we have a number of journeys. So we do both ways. Yep.
Do the different teams have a responsibility for different microservices, or do all teams do all microservices?
No, we have guardianship, and each microservice has been appointed to a team. And you have a combination of microservices that actually built an application, and they share that. So we have a related standby for the total, but each of the team has a guardianship of one of the microservices. Yep. Other questions?
Was it hard to start working on mainline only?
Yes, it was hard. And two things to hard. One of the things is that lots of the developers are used to in GitFlow workflow, and the discussion I have with them is, well, you have two things to it. One of the things you merge, so you have a gap in feedback. Well, you have feedback, but not your team. And the second one is you are going to work in a cocoon. And some of them are working that, but they use short-lived branches and they communicate and stand up and what they're working on. But other teams which are not mature, they tend to keep that by themselves, and then after a mid-sprint or at the end of the sprint, we have seen that, then commit that to the master. And that's very good, but you are doing that, your teammate is doing that, and your next teammate is doing it, and he has to ship because he has to solve all the problems. So yes, it is hard, and it still it's still hard to make people understand what mainline development is and what the actual benefits are. That doesn't mean that we don't have any long-lived branches. Some of the times you have an R&D, some experimentation, and then we tend to use a long-lived branch, but then that's also being read and not merged into master. But that's actually a very good use case for doing more long-range branches. Within the bank, I'm still administrator on the Git repository, and I've seen Git repositories had branches with caps of 2 years or further. So who's going to look into that? So one of the things that part of one of the slides is also hygiene of your environment. We have a very aggressive cleaning philosophy. So if you don't use it, within a couple of days, and depends on part of the application working on a part of the artifact you make. If you're going to not use it within a couple of days, well, it is so outdated, please remove it. I have lots of discussion with one of the supporting teams is that they want to migrate all data from SonarCube. Well, if it is longer than 3 months, probably nobody looks into that, so it's being all data, please get rid of it. And if it's a problem, then run it again and build it again. And that's also mean for snapshot. Snapshot could be a very aggressive cleaning. Well, probably you don't know what's in it, and secondly, it takes a lot of effort for maintaining that environment. So snapshot also within 3 months, move it away, because or you make a release on it and then it delivers business value, or it is waste. So please remove it. Yep.
When did you remove the WebSphere?
That was around 2016, and then we were changing from the monolith environment to a microservice environment. We have still one of our application is on a WebSphere environment, and we're currently migrating that because two things. One, PIF, that's the portal platform, is outdated, end of life next year. WebSphere should be upgraded. We're running Red Hat 6, and that's end of life. So we have to upgrade that, and now we're going to move that to the Messrs Marathon environment, or the next step probably is our Kubernetes environment we're going to. But it's also going to Azure. A number of applications also running in Azure. The only thing that limits us is the database that's currently supported there, but we also have that now in place with our standard operating procedures and moving all the things there.
And
so it's very optimistic that the Ghost guy 4 years are going to the new environment, to the cloud, because it takes a lot of time for doing that, and not going to underwater and doing the technical stuff, because if you're doing only technical stuff on non-functionals, then you're not delivering value to our customers. So it's repairing Boeing. Well, Boeing Max is a little bit scary now, but it is repairing with the shop open, and that makes it also dynamic. Yep.
So Spring Boot everywhere.
Spring Boot everywhere. Yeah, we do that. And we have Spring Boot, including the metrics, the actuator, logging for that. That's our philosophy. So we also, what we did was using Spring Cloud config for doing that. Currently also introducing HashiCorp Vault for security parts. Auditability is increasing. The standards of ISO 27001 security is also increasing. So people tend to have the same service levels if they're going to Bol.com or Amazon.com. I ordered today, and today I've got it in my postbox, and that's the same level that we need to provide to our teams, and that's the same level we're going to do to provide to our customers, and that's internal and external. So the level, the playing field is rising, and costs are going down, so the cost should be going down.
Just out of curiosity, what was your reasoning for choosing Vault? Specifically Vault, and not?
It had a good integration with the configuration server, neatly. So you that was the main reason. We had some other standardized application within the environment over here, but that couldn't handle the seamless integration. And we had a cattle environment, so I don't know where something runs. It runs somewhere, and it can crash and it can update again. So that was the main reason for choosing Vault. We're still debating with enterprise architecture or the lead business architect, but well, it couldn't solve the problem we have with the current product set.
And is Vault running on console?
We use Vault and console. Yeah, we're on that. And that runs on the Mason Marathon platform. One of the discussion was also going to cloud and high volumes of log data. So the Alex stack we currently run also on-prem, but we are going to host that on the Azure platform. So all the Azure logging is going to the Azure stack, so we keep the data over there, and only you pay for, we have an express route, so paying for getting data from Azure is not currently not are no cost for us. The actual running the application did do run of gives costs, but the data stays over there, and that prepares us for going to the public cloud. Questions? No one? If you want to see and you're part of the Rabobank, all our applications are, all our built applications are Jenkins are public. You can't modify, but you can access that for looking into how we do that. But that's only for the guys within Rabobank.
And the repos are also.
Sorry?
The repositories are also
No.
open.
No,
for
no,
Rabobank.
we have one of the things that I'm very fond of is open source, and then inner source within our environment. So our team makes some of our tooling available for others to to make use of it and make your own configuration for it, make your own additions, so we can together go better. So we don't have we have a site with a reliability team like Google has for managing our environment, so Mass Marathon and others, but actually doing that is by the teams for the teams. So the teams actually provide also and working on the Jenkins pipeline library, on some of our supporting Spring Boot application. One of the things we do is some of the other systems are logging data into Kafka. We have a Kafka bus like the business event bus, and provide logging on that. And we have some made an application for retrieving that log and to make that within our Elk environment. So each of the components with our chain, we can log and make dashboard on that. Even if we don't actually have Splunk access, we use the BAP for listening to that. So one of the things are available, they are public. Our Docker images hardened are available. We, as I mentioned, on the local environment, also some of the runtime environment, we have Docker environments. We use distributed images, so they are hardened. We have security on that, so that we use hardened Docker images, and we also scan them. That's one of the improvements that we're going to do, scan them with Nexus IQ for vulnerabilities. So that's one of the things that I'm currently working on. There's some of the public, not all. I thought there wasn't still, no question? Okay, thank you very much.